Welcome. Earlier, you have learned about probability distributions of single random variable. In this lecture, we will do probability distributions of more than one random variable. Now the question is, why do we need probability distributions of more than one random variable? For example, if we want to study height and weight of a group of randomly selected students, then you can assign one random variable, say x, to height and another random variable y to weight. After that, you may be interested to calculate whether there is any relation between height and weight. So there are various situations where we need to consider more than one random variable. So let's start with the mathematical definition of a bivariate discrete random variable. If x and y are two discrete random variables, then x comma y is called a bivariate discrete random variable. Okay? If x and y are two discrete random variables, then x comma y, this pair, is called a bivariate discrete random variable. Now let's define the PMF, in fact, joint probability mass function of x comma y. Before that, I assume you know the PMF of a single discrete random variable. What's it? A function f is said to be PMF of a single discrete random variable if it satisfies three properties. Number one, fx is greater than or equal to 0. Number two, fx gives probability for each value of x. Number three, sum of all values of fx is 1. This you are already familiar. Now let's see what is joint probability mass function of xy. A function fxy is said to be joint PMF of xy if it satisfies three properties. Number one, it should be greater than or equal to 0. Number two, it gives probability for each value of x and y. Third, sum of all values of fxy over x and y is 1. You can compare the two definitions. We have double summation in place of single summation. Next, we define marginal PMF of x and y. These are defined as fxx equal to sum of fxy over y and marginal PMF of y is defined as sum of fxy over x. These are additional definitions. These are not there, of course, in case of single discrete random variable. Now let's move to the next definition. expectation of a general function of xy is defined as summation over x, summation over y, hxy, fxy. You can recall the definition in case of single discrete random variable, where the expectation of a general function of x is summation over x, hx, fx. In particular, expectation of x is summation over x, summation over y. This hxy is replaced by x. This is called mean of x. Here we give the notation mu x. In case of single random variable, ex is summation over x, x fx. That we denoted by mu. Likewise, you can define expectation of y, and we can denote that by mu y. Okay? Now let's see the next definition. It is covariance. Covariance of x and y is defined as expectation of x minus mu x into y minus mu y. If we simplify it further, we get exy minus ex into ey. Recall that variance in case of single random variable is defined as expectation of x minus mu whole square. In simplified form, it reads as ex square minus ex whole square. So covariance is just a definition analogous to variance. You see, if I put y equal to x here, it gives me variance. So here we give a similar notation, sigma xy. In case y equal to x, you get the formula of variance. But covariance has, of course, a different meaning. You will see this later. Now there is one more definition, that is independent random variables. If joint PMF of xy is equal to product of marginal PMF of x and y, then x and y are said to be independent. And remember that this should happen for all xy, for all values of xy. If this condition fails even for a single pair xy, then xy are not independent. Up to this it's fine? Okay. Now we can also define CDF, or cumulative distribution function of xy, denoted by fxy. It is defined as sum of probabilities up to given values of xy. Up to given values of xy. If you recall, in case of single discrete random variable, the CDF is sum of probabilities up to x. So this definition is just analogous to the single variable case. Fine. So after having these definitions regarding the joint discrete random variable, we can do a couple of examples to understand these definitions in a much better way. Okay, so let's begin with the examples now. Example 1. Suppose we toss two fair coins, then you know the sample space is S equal to HH, HT, TH, TT. Next, suppose X denotes number of heads and Y denotes number of tails. Can you guess what are the values of X and Y in this case? X values are 0, 1, 2 because number of heads could be 0, 1 and 2. Likewise, number of tails can be 0, 1, 2. So you are ready with the values of your random variables. Now the next task is to write its probability mass function, means fxy. See how do we calculate it. Okay. So it's always better to represent fxy in the tabular form because there you can understand that how the probabilities are to be written. So in this column you have x values 0, 1, 2 and in this row you have y values. Here we need to write probability corresponding to x equal to 0 and y equal to 0. So what's the probability? What is the probability in the case 0, 0? Probability is 0. Why? Because if you toss two fair coins, there is no way that there is no head and no tail. Likewise, 0 head and 1 tail is also not possible. So probability in this case is 0. Probability for 0, 1 is 0. For 0, 2, 0, 2 means 0 head and 2 tails. This is possible. So what's the probability for this case? 1 over 4. Similarly, what is the probability corresponding to 1, 0? It's 0. 1, 1, 1 head, 1 tail. These two cases, probability is 1 by 2. Probability corresponding to x1 and y2 is again 0. Similarly, you can think probability of getting 2 heads, 1 by 4. Probability of getting 2 head, 1 tail, 0, 0. Okay. So this table gives you probability of all values of xy. So this table represents your fxy because all possible values of xy are given and their corresponding probabilities are given, right? Now, can we calculate marginal densities of xy? See how do we calculate? If we sum the probabilities along y values, we get marginal density of X by definition, or marginal PMF of X. If we sum along X values, we get marginal PMF of Y. So what are the values? Let's say along Y values. Means what is the sum of probabilities along Y values? This addition of the 3 is 1 by 4. So in symbols, what's it? It is fx0, marginal probability mass function of X at X equal to 0. Similarly, second one is 1 by 2, third 1 by 4. So these are fx values at 1 and 2. This side, if we sum along X values, we get marginal PMF of Y. So what are the values? 1 by 4, 1 by 2 and 1 by 4. After that, you may also see that these all values, the 9 values, are really the values of joint PMF of XY. Yes, because sum of all the 9 values is 1. You can see the column-wise addition or row-wise addition. You are getting 1. So it's really joint PMF of XY. Also, now you have shown the marginal PMF of X and Y. Okay. Now further, suppose I want to calculate expectation of X. How to calculate it? How to calculate expectation of X? First, recall the definition of expectation of X. It is summation over X, summation over Y, X times fxy. So thing is that you have to perform that double summation over these values. But we can avoid solving double summation. Actually, we can rewrite this formula. Summation X equal to X. I can take X here. I can take that X here outside this summation, because for this summation X is constant. But what is the remaining thing? What is the remaining thing by definition? It is marginal density of Y. No, marginal density of X, because you have summed over Y. Marginal density of X. It means if you multiply X values with the corresponding marginal density of X values, then we can get expectation. In this case, you need to solve only one summation. Now, where are these values? See, these are X values and these are fx values. So just multiply 0 with 1 by 4, 1 with 1 by 2, and this 2 with 1 by 4. What do we get? It's 1. Likewise, you can do yourself. Expectation of Y. In that case, you need to multiply the Y values with the corresponding values of marginal density of Y. So you can do this calculation yourself. You will get 1. Okay. Next, if I want to calculate EXY, what to do? By definition, EXY is summation X 0 to 2, summation Y 0 to 2, XY, fxy. So how to perform this double summation? In this case, we need to multiply XY values, X into Y values with the corresponding fxy values. So let me tell you an easy way to do this. You have already the table for fxy. Let's create a new table for X into Y. Here you have X values, here we have Y values. So if I write X into Y, so 0 into 0, 0, 0, 0 into 2 is 0, 1 into 0, 0, 1, then 2, then 2 into 0, 0, 2, 4. So this is this table is for XY, this table is for fxy. So what to do to perform this summation, double summation? just multiply the corresponding values of table with this table and add. Is that okay? So what do you see? 0 into 0, 0, 0 into 0, 0, 1 by 4 into 0. Okay? So it's very easy to see that just you need to multiply 1 by 2 with 1, because all other multiplication would give you 0. So you get 1 by 2. See this table again. This is x into y table. This is fxy table. So if you multiply corresponding values of this table with the values in this table, then you get 1 by 2. You can check it yourself. Fine. Now one more thing we can calculate, because now we have ex, ey and exy. So what's covariance xy? Recall the definition. It's exy minus ex into ey. So what is the calculation for covariance xy? It is 1 by 2 minus 1 into 1. Finally you get minus 1 by 2. So this is covariance of xy. Okay? This is covariance of xy. One final thing in this example, what can we say about the independence of x and y? Independence of x and y. Let's calculate. In fact, we need not to calculate. We can see from here the value of fxy at 0, 0, at 0, 0. The value of fxy is 0 at 0, 0. And the marginal PMFs at 0, 0 are fx at 0 is 1 by 4 and fy at 0 means this value is 1 by 4. You can see that value of fxy at 0, 0 is not equal to the product of marginal PMFs at 0, 0, because here the product is 1 by 16 but value of fxy at 0, 0 is 0. Both are not equal. What does it mean? X and y are not independent. Fine. So I have solved one complete example for you. Now we can move to the next example. Example 2. Suppose there are 3 blue balls, 2 red balls and 3 green balls in a box. Suppose there are 3 blue balls, 2 red balls and 3 green balls in a box. 2 balls are drawn at random from the box. 2 balls are drawn at random. Suppose x denotes number of blue balls drawn and y denotes number of red balls drawn. Then can you tell me what are the values taken by x and y? First think about x. How many balls are drawn? 2 balls are drawn. How many blue balls are there? 3. So what values x can take? 2 balls are drawn. There is a possibility that there is no blue ball in the drawn balls. So x can take the value 0. There can be 1 blue ball. Both balls can be blue. Likewise, y can take which values? 0, 1, 2, because there are two red balls. So now you know the values of your random variables. Next thing that you need to do is write the joint PMF of xy. Joint PMF of xy. Can you write it? Means you have to write probabilities of fxy for each value of xy. In this case, you can write a compact formula also for all the probabilities. See how. Two balls are drawn out of 8 balls. There are total 8 balls in the box. 2 balls are drawn. So it is if 0, okay, x balls are coming which are blue. So out of 3, x balls can be drawn in how many ways? 3cx ways. Y balls are coming from 2 red balls. So that can happen in 2cy ways. Remaining balls means 2 minus x minus y are coming from these 3 green balls. So this can happen in 3c2 minus x minus y ways. And how can you draw 2 balls from 8 balls? In how many ways you can draw 2 balls from 8 balls? 8c2 ways. So this is general formula, or you can say compact formula for fxy. Here, notice that this x plus y should be less than equal to 2. If x plus y is greater than 2, then naturally the probability is 0. Okay? So now you can write your table using this formula. I'm writing the table, you do the calculations yourself and see what you get. So these are x values, these are y values, 0, 1, 2, 0, 1, 2. Corresponding probabilities you can calculate from this formula, and these are 3 by 28, 6 by 28, 1 over 28, then 9 over 28, 6 over 28, 0, 3 over 28, 0, 0. Once your table, then you can do further calculations for marginal PMFs, expectation x, expectation y, and you can calculate covariance. Then you can also see whether the variables are independent or not. So those kind of questions can easily be replied from the table. Okay. Now let's see the next example. Example 3. In an automobile plant, robots do 2 jobs. Number 1, welding of 2 joints. Number 2, tightening of 3 bolts. Okay. Suppose X denotes number of defective joints and Y denotes number of improperly tightened bolts. Suppose these are 2 random variables. denoting number of defective joints and number of improperly tightened bolts. Okay. After that, the joint PMF of F is given to you. I am writing it 0, X values. Okay, before that, what are X values? X denotes number of defective joints. How many joints are welded by the robots? 2. So what values X can take? There may be 0 defective joint, there may be 1, there may be 2. So X can take the value 0, 1, 2. What values Y can take? Y denotes the number of improperly tightened bolts. And how many bolts are tightened? 3 bolts. So it is possible that there is 0 improperly tightened bolt, 1, 2 and 3. So Y can take 4 values in this case. Okay. Now probabilities are given to you. These are 0.84, 0.03. So this is the table for fxy in this problem. This is given to you. Now the first question is whether this is PMF of xy. So how to check it? How to check whether it is a PMF of xy? It's very simple. Just add all these values. If you are getting 1, it's PMF. So you can check sum of all these values is 1. Okay. You can also write marginal densities fxx and fyy. These values are 0.9, 0.08, 0.02. Then 0.91, 0.045, 0.032, 0.013. You can check sum from either side, it's 1. So it's joint PMF of xy. Okay. After that, the question is, what is the probability that there is exactly one error done by the robots? Listen carefully. Find the probability that there is only one error made by the robots. Probability, exactly one error. What does it mean? Exactly one error means either x is 1 or y is 1. Means you need to sum the probabilities x0, y1, x1, y0. Okay. Where is f01? f01, 0.03. And where is f10? 0.06. So in this case, the answer is 0.09. Okay. Second part in the same problem. Find the probability that there is no improperly tightened bolt. Probability of no improperly tightened bolt. What does it mean mathematically? No improperly tightened bolt. See, so in this part we need to calculate the probability that no improperly tightened bolt. There is no improperly tightened bolt. What does that mean? Y is 0, but x can take any value 0, 1, 2. So in this case you need to add these three probabilities because y is 0 in these three cases and x can take any of these three values. So what is their sum? 0.91. So just you can add those three and write your answer as 0.91. Okay, after that you need to check whether x and y are independent. I think it's simple to check. You see the value of fxy at 0, 0. What is it? 0.84. And what is the value of fx at 0? 0.9. And value of fy at 0, it is 0.91. You can see clearly product of these two, product of the marginal densities at 0, 0 is not equal to the value of joint density at 0, 0. So x, y are not independent in this case. Okay. Also, you can do one more calculation yourself. You can calculate covariance in this case. For that, you need to calculate Ex, Ey, and Exy. I'm just writing the answer of Ex, Ey, Ex, Ey, and Exy. You can check it later. The values are 0.12, 0.148, and Exy value is 0.064. From these you can write your covariance value. It is 0.046. Fine? Okay. Example 4. What's the statement here? If x and y are two discrete random variables, taking only positive integer values, x and y are two discrete random variables, taking only positive integer values, their joint PMF is given by C over n into n plus 1, where C is some unknown constant and 1 less than equal to y less than equal to x less than equal to n. This is given to you. Now the first question is, what is the value of C? So what would you like to do to find C? Or what you have to do in fact, you have to double summation this function over the given ranges of x, y and put that summation equal to 1 to get C. Because double summation of joint density over the given ranges of x, y is always 1. So using that condition you will get C. But this problem is not straightforward. Be careful about the given ranges. Let's draw the given values of x, y. Here I draw the line y equal to x. Okay. So first value of xy is 1, 1. Xy is 1, 1. Then what are the other points? 2, 2 and so on. Final point is on this line is n, n. Then you have let's say this is 1, 1, 2, so on. This point is 2 comma 1. This is 2 comma 1. Like this you have other points here, then here, then here. So I draw a parallel line through these points. What is this point? This is 1 comma 1, this is 2 comma 1, 3 comma 1, last point is n comma 1. Okay? Then you have a point here like this. So you see that all your points are lying in this triangular region. Why we have not taken points above this line? Because it is given that y is less than or equal to x. Y cannot be greater than x. For the points above it, if you think directly, you may be thinking that x is varying from 1 to 3 and so on. Y is also varying from 1 to 3 and so on. 1 to n, 1 to n. But among these pairs, you have to choose those values of x, y where y is less than or equal to x. If you consider all the points, then you will get a rectangular shape in which the points are lying. But according to the given condition, you need to consider the points where y is less than x, or you can say below this line. Now let's do the calculation for finding c. For finding c, what you need to do? Sum over x, sum over y, fxy is equal to 1. Now, x goes from 1 to n, y goes from 1 to x. I am not writing y from 1 to n. Why? That point you need to understand. I hope you know the double integrals, where you draw a ray through the given region and decide the limits. Because here the region is not rectangular, it is triangular region. So what you need to do? You need to choose a ray through the region. So I'm choosing a ray through the triangular region, and you can see where it enters, where it leaves. It enters at y equal to 1, and where it leaves on the line y equal to x. That's why I have taken limits of y from 1 to x. And limits of x are of course 1 to n in this region. Now let's do this calculation further. Summation x from 1 to n. This is constant. This is constant, and y varies from 1 to x. So this is added how many times? X times. This is added x times. So you can write cx over n into n plus 1. Next, c over n into n plus 1 is constant. You can write outside the summation sign. Summation x 1 to n x means 1 plus 2 plus 3 and so on up to n. What is that summation? You know that familiar formula, n into n plus 1 over 2. So finally, these are cancelled and you get c equal to 2. Okay? So you have found your c. So now you know your fxy. Fxy is 2 over n into n plus 1. Okay? Now, next part in this question is find marginal density of x. Marginal density of x. What is marginal density of x by definition? Sum over all y, and y varies from 1 to x, of fxy. This is your fxy. You sum over y. What do you get? You get 2x over n into n plus 1. What is marginal density of y? Marginal PMF of y. This time you will sum over x. So x goes from, choose your ray through the region parallel to x axis. See where it enters. It enters at x equal to y, and where it lives? It lives at x equal to n. So the arbitrary ray through the triangular region parallel to x-axis enters at x equal to y line and leaves at x equal to n. So x limits are from y to n. Okay, and here of fxy. Here fxy is 2 over n into n plus 1. You can substitute here. What is the summation from y to n for this constant 2 over 2 over n into n plus 1? 2 over n into n plus 1. This is added how many times? For x varying from y to n. N minus y plus 1. So these are marginal densities of x and y. One more part you can do in the same problem. What is it? Suppose n is equal to 5. Suppose n is fixed to 5. What is the probability for x less than equal to 3 and y less than equal to 2? So which pairs of xy you will consider? Where x is less than equal to 3, y less than equal to 2, but one more condition, y should be less than equal to x. So which pairs satisfy this condition? Can you check? 1 1, 2 1, 3 1, 2 more pairs, 2 2 and 3 2. For n equal to 5, the probability is constant for each. So you can add the 5 values and finally we'll get 1 over 3. Okay. So up to this I have covered bivariate discrete random variable. Next time when we will meet, we will do the case of joint continuous random variable. Okay.